you know, it can get pretty congested pretty quickly in terms of the number of truck trips that are necessary to support it. You know, you're going to first start off, you need fresh water that's got to get to each of the wells. So you start putting lots of trucks on the highways. Again, that's traditionally the #1 public concern that's always mentioned is the just sheer volume of trucks. The best practices had always been take in clean water, take dirty water out, and dispose of it someplace. So how can we do that more efficiently and sustainably? In our case, you know, we look at it as how can we go where our client's activity is, rather than focusing on just centralized treatment facilities where everybody has to drag it to us. Let's go near field or fixed field where their drilling program is going to be. Again, if they're going to now start drilling 6, 8, 10 wells on a pad site, and they've got 10, 12 pad sites in a 3,000 contiguous acre area, well, they're going to be up there operating for 18, 24, 30 months. So let's locate with them so that we can take as much of that or mitigate as much of that truck traffic as would be possible. So what you see a lot today is fresh water's being moved by pipelines. They're either burying them or they're going right on the surface of the ground. So they're pumping water from the rivers to large impoundments and then delivering water on the frac job live. So they don't stage all the water on a well pad that they need to develop the well. They'll pump actively during the frac job from a large reservoir. And then same thing, some companies are actually moving generated waters by pipeline as well back to a centralized location. There's some concern yet, is that regulatory sustainable? Some groups are already practicing it. Others are waiting for more clarity, definitive position from the DEP with respect to what design criteria do I need to meet if I'm going to practice it that way. From our position, you know, you can never eliminate all the trucks. There will always be trucks in the equation. While you can mitigate it as best you can, you know, by putting a fixed field or near field facility up in their drilling program where we're processing this water on their behalf, we can keep the majority of the trucks off the main interstate highway systems, keep them back there in that well development program area as best we can. And then it may be a combination of both trucks, pipelines, you know, all those different activities. So that's kind of where we're migrating towards in support of the industry going forward. In fact, we anticipate having, you know, our first fixed field facility operational yet this year. Co-worker of mine says it best. We have a facility. It was the first of its kind in the Commonwealth it was dedicated to Marcellus activity where we have a residual waste beneficial reuse permit. We were the first in the Commonwealth to obtain that. We worked, you know, very collaboratively with DEP because they had no permit vehicle by which to, you know, permit such a facility. So we had to work with them to determine, is this a water quality? Is this a waste management? Is this air quality? And, you know, figure out which elements from all the different bureaus of the DEP were applicable, and then make sure that we adhered to all those criteria in our permitting process. Ultimately, you know, that same Gen 1 facility, which is really just removing suspended solids and those metals that are contained in the water, not doing anything to remove the salts. Some point in time, it will need to transition to our Gen 2 thermal processing such that it can ultimately discharge back to the environment. The same Gen 1 treatment equipment is necessary in advance of any thermal processing system in order to protect it from the metals and things like that that'll scale out on the heat exchangers and so forth. So really it's just an addition to an existing operation at that point in time. Just a little bit of, I guess, history. I talked about our permitting. Since obtaining our permit in April of last year, so we just went over our 1-year anniversary, we've received, processed, and returned in excess of 42 million gallons of water. We're permitted for 400,000 gallons per day. We currently bump along somewhere around 35–40% utilization, so we have more capacity available. And it's interesting that we have both ends of the spectrums in terms of clients. We have small independent clients that may do a dozen, 50 wells a year, and then we've got the large multinational clients that are going to do maybe 200 wells a year in terms of their program. One client only sends us produced water. Their flowback water that has been in contact with the formation for the least amount of time, which is not that bad in terms of its waste characterization. They just take that, they filter it, they blend it right in with their fresh water, and away they go. Their produced water, however, they wanted to have it managed. The small client, they want to have all of their water treated. They want to have it treated down to a very low level in terms of metals, so that they're protecting their reservoirs best that they can. So as you can imagine, produced water comes in nice and steady. Every well that comes online, for every M of gas produced, you get 4 to 6 barrels of produced water that's generated. So that's nice and predictable. You get nice and steady all the way across there. When you're processing or managing flowback water for a client, you get huge spikes, because they'll start flowing back several hundred barrels per hour, and that flowback will occur for several days before it really starts to peter out, and then you're just down to 10, 20, 50 barrels a day in a short amount of time. So we have to have the flexibility to accommodate both clients. Some days we'll have that 35% utilization, then 2 days later we'll be at 100% because we're actively flowing back from one of our clients' wells. The Gen 2, some of the things that in both situations, because we are a DEP permitted, regulated facility, upon discharge from a truck at our facility, we take ownership of the water. We retain ownership of the water until we push processed water back onto that same truck to take it back out to the well field. So from the energy company's perspective, that adds a layer of protection for them, if you will, and that there is a third party responsible between management of that waste that they generated to it's either beneficially reused or disposed of. We do create a filter cake as we process the water. We are responsible for that. We send it to a permitted landfill in Western PA. And again, we are the responsible party for those solids that are created. The real question for the thermal processing, the Gen 2, some people have already advanced it throughout the Commonwealth. There's facilities being constructed at this time. The question is if you're now going to be removing the salts, what do? Do you stop at brine concentration, or do you drive it all the way through crystallization and end up with a dry residual that now still needs to find some use for it? Do you put it in a landfill? Maybe, maybe not really sustainable. Is there a market for that large volume of salt, whether meets commercial grade for any particular industry, or it can be road applied or anything like that? From my perspective, all the work that we've done to date, we'll stop at brine concentration and then send that highly reduced volume. You might get 85% volume reduction in running it through a thermal processing system. Now take that highly concentrated brine and send that to a UIC, whether it's in Pennsylvania, Ohio. Some people are putting it on rail cars and sending it as far as Oklahoma and Texas at the present time. This is a diagram of our facility, just real quickly. Water is put on a tanker truck or the triaxle trucks, currently driven to our facility. It's right there in Williamsport. We test every single load prior to accepting that material. We reserve the right to refuse any load that we don't think fits our bandwidth. The criteria that we look for, are some basic things such as pH. We want to make sure it's in 4 to 10 pH range. Make sure it's not more solids than it is liquid. We have literally received, loads that were 90% sand or drill cuttings or something other than water. We're a water processing facility, not a solids management facility for the industry. And then the other thing that we test for is normally occurring radioactive material. Every single load we test for it. We make sure that it is within our bandwidth for our permit that we've obtained. We consulted with a certified health physicist, the same type of an individual that would manage a radiology program at a large medical center or something like that. To date, our experience has been after over 8,000 individual discrete data points. Yes, there is norm in this water. Our highest data point to date is we measure in micro-hour per hour. We measure an activity level, has been 16 micro-hour per hour. At our facility, ambient background level at that location is about 7 to 8 micro-hour per hour. So it's not that much greater than just ambient background, normally occurring radioactive material. As we process that water, yes, the norm does tend to follow the solids, which we separate, dewater, put in a roll-off. They do concentrate in our roll-off. We are approved through our radiation safety plan up to 175 micro-hour per hour. And then that can legally go to a landfill in Western Pennsylvania. Our highest level to date for our roll-off has been 150 micro-hours per hour. And 99.9% of the time, it is the norm of concern is radium-226. We can talk a little bit more about the treatment and the chemistry that's associated with it. But basically, from the time the truck arrives at our site, concrete containment slabs, so any drips, leaks, spills, anything like that that may occur are collected, directed into our facility, goes through a large filter just to screen. You can't imagine anything that fits in a 4-inch hose. We've seen, cans of WD-40, gloves, shoes, anything like that. Anything that fits in these 4-inch hoses in these trucks, we've received at our location. So we screen that just to protect our downstream pumps and storage tanks and those types of things. It first goes into the brown tanks. One of the things that's very much different about our operation as compared to anybody else's is we do not commingle anybody's water. So we segregate client A's and client B's water all the way through our process. That way there's no concern by that energy company over, do I got anything in there that's not compatible with my well development program. They can follow with their RCRA, cradle to grave process, and it just keeps it cleaner on our end as well. A lot of times it'd be nice to blend waters, but we intentionally segregate everybody's water. We process it in batches so that at the same time that we segregate it on the front, the processed water is also segregated on the back. Once that truck is done offloading its contents, it simply takes that hose that it discharged the dirty water through, connects it to a different standpipe, and we push processed water back on that same truck. So at the very minimum, we're making that truck run full all the time rather than half tripping, going back empty. So from, footprint, carbon, greenhouse gas emissions, all those types of things, we've cut that number in half by just being able to put processed water back on the same truck. It is a very traditional physical chemical treatment process, very much like many industries that are throughout the Commonwealth and U.S.